Factor theorem from algebraic expressions. In this, we'll look into the statement, representation, proof, and application. Before learning factor theorem, we have to know the remainder theorem and how to apply it. For that, check the description. You'll get the link there. Now, as a brief of remainder theorem, we know that when any polynomial f of x is divided by x minus a, then it leaves a remainder of f of a. So we are going to divide this. In that case, we'll get remainder as f of a. Now coming back to the factor theorem. The statement is if f of x is any polynomial of degree greater than or equal to 1 and a be any real number, then x minus a is a factor of f of x if f of a is equal to 0, or f of a is equal to 0 if x minus a is a factor of f of x. This is related to division of algebraic expressions. For divisions, we know that dividend is equal to divisor into quotient plus remainder. And any algebraic expression can be written as f of x, that's the dividend, is equal to x minus a into q of x plus r of x. In this, we are specifically dividing the expression with x minus a, that's the divisor, which leaves a quotient q of x. Q of x means quotient is in terms of variable x plus f of a. Remainder is written as f of a. This is from the remainder theorem that we have just looked in now here. F of a is the remainder. From this equation, we'll try to understand the factor theorem. The first statement states that x minus a is factor if f of a equal to 0. In this equation, when we keep f of a is equal to 0, that gives f of x is equal to x minus a into q of x. We'll try to understand this with help of a numerical value. Say 6. In place of f of x, we are taking 6. 6 equal to 2 into 3. Then what can we tell? 2 and 3 are factors of 6. In similar way, when we keep f of a equal to 0 in this equation, here we can tell that x minus a is factor of f of x and q of x is also a factor. These two are factors. So when f of a is 0, it makes x minus a as a factor of f of x. Coming to the next thing, f of a equal to 0 if x minus a is a factor. When any number is factor, then f of x can be written as that particular factor into another factor, and that gives no remainder, which means that f of a is becoming 0 in this case. So when x minus a is factor, f of a will become 0. When f of a is 0, x minus a will become a factor. We'll try to understand this with help of an example. Let us take this expression f of x. Then we have to check if x plus 2 is a factor or not. When can we tell x plus 2 as a factor? If x minus a is a factor, what happens? F of a will become 0. So just check whether f of a is 0 or not. From that we can conclude whether this x minus a is factor. For x plus 2, how can we get the value of a? See, x plus 2 can be written as x minus of minus 2, because minus of minus is nothing but plus. Now this is x minus a. In place of a, what we have here? Minus 2. So for f of a, just do f of minus 2. We'll try to do from this f of minus 2. Substitute minus 2 in place of x, that makes minus 2 whole cube plus 3 into minus 2 whole square plus 5 into minus 2 plus 6. Simplify this, this gives minus 8 plus 12 minus 10 plus 6. Now plus 12 plus 6 makes 18, minus 8 minus 10 makes 18. So 18 minus 18 is 0. That makes f of minus 2 is equal to 0. X plus 2 is a factor because f of minus 2 is 0. In this way, without doing actual division, we can know whether a given linear polynomial is a factor or not. Now we will try to check the second statement also. That is f of a is equal to 0 if x minus a is a factor that we have seen now. We will check the other way. X minus a is a factor if f of a equal to 0. For that we will take an expression. Let us take f of x is equal to x cube plus 9x square plus 27x plus 27. This is the thing, and now x minus a is factor if f of a is 0. Means we have to know some f of a for this expression which would be equal to 0. From that we will try to obtain the factor. By observing this, we know that x should be some negative value as we have all plus here. I'm taking f of minus 3. We do f of minus 3, that is minus 3 whole cube plus 9 into minus 3 whole square plus 27 into minus 3 plus 27. Simplify this. This is minus 27 plus 9 into 9, 81. 27 into minus 3 is minus 81 plus 27. Plus 81 minus 81 minus 27 plus 27 equal to 0. F of minus 3 is 0. So what is the factor for this f of x? We have to write this as x minus a. In place of a we have minus 3. So minus 3. Minus of minus is plus. So this can be written as x plus 3. So x plus 3 is factor of this particular f of x. So we know this particular f of a is 0. For f of minus 3 it's 0. From that the factor is x plus 3. In this video seen the definition of factor theorem, how to prove both the statements of the factor theorem and uses of that.